Good evening, Dr. Sai Ramesh, sir. Am I audible?
Yes, sir. You're audible, sir.
Good evening, one and all.
Good evening, sir. Good
Actually,
evening.
today we have some technical issues. Some of our association members are unable to join. That's why I shared with them the YouTube live streaming, let them to listen the session. Today, wholeheartedly, on behalf of the Association of Global Academician and Researcher, on my own behalf, I would like to welcome today's speaker, Dr. Sai Ramesh from Wales University, who is assistant professor in the Department of Bioengineering, School of Engineering, Wales Institute of Science and Technology, and Advanced Studies, Chennai. Actually, we utilize to his expertise in our Sacred Heart College International Conference, but we got his opportunity today on behalf of our NGO. Sir is going to enlighten us with his talk on plant-derived antimicrobials in the fight against AMR. Now the session is for the resource person. Over to you, sir. Please proceed, sir.
Sir, thank you for the introduction, sir. And I have a small request. Can I just get my screen sharing game being enabled?
Sir. Yes, sir, yes. Now you can proceed, sir.
Yes, sir. Sir, is the screen visible, sir?
One second. Yes, yes, sir. It's clear, sir.
Yes, fine. So let me just take a moment to thank all the organizers for inviting me to give a small guest lecture kind of introduction on AMR, that is specifically plant derived antimicrobials to fight against AMR. So this will be a mere an introductory session where we are not going to deal with any complicated information, but a vital one and a need for the hour for this particular period of growth in the field of medical biology. So myself, Dr. A. Sai Ramesh. I'm presently the assistant professor in the Department of Engineering, School of Engineering in Wales, Institute for Science, Technology and Advanced Sciences. So in the 72nd World Health Assembly of World Health Organization, they have very clearly mentioned that there will be a need for research in the field of antimicrobials. So why do we need this particular field? Why WHO started to speak on this? We need to know initially before we get into the crunch of the information. And when it comes to AMR, the recent disease that we have encountered is COVID, and many people are fear of COVID deaths. But remember, if we are not going to concentrate much on AMR, the the cumulative death count that we saw for the 5 years due to COVID will surpass in 2050 just because of AMR. AMR can take the toll equivalent to COVID with humans, it of 50. So it is the right time we invest our research microbials can be avoided. Terminology introduce what things are so that AMR. So there are certain words that we are very mixed, and there are many people who just move into pharmaceutical uh, places or shop, get into the drugs over the counter, which is usually shouldn't be the case. So what antibiotics are is a mere chemical substance produced by a micro that possess selective inhibition, which could kill any other microorganism. So these antibiotics kill only bacteria. They don't kill viruses. That is why we don't treat or provide antibiotics when you get common cold. For a common cold, there is no drug. It has to be treated as such, and over a period of time, it gets cured on its own. When it comes to antimicrobes, it is a much broader term. There is no selective inhibition as how we say antibiotics. In public, there is a misconception. Antibiotics goes for every organism if it kills. So antibiotics actually mean a bacterial infection could be cured when you consume it. And what are we looking for is not antibiotics. We are looking actually for antimicrobials without any selective inhibition, which includes bacteria, fungi, viruses. So I am looking for a selective substance, especially from plants, as per my topic is concerned, which can be treated against or a virus or any parasitic infection or fungus. This is what we are going to look for, or the world now needs a suitable, efficient AMR, which we are lagging now. Now, a question is being raised. Is it a concern? What is happening with the present antibiotics? The current situation was already being discussed by the Nobel laureate Sir Alexander Fleming. Many people know him for his invention. He is a person who was instrumental in the discovery of penicillin. And at that time itself, he said there will be a day where people will start using penicillin without proper consent, and this penicillin will lose its effectiveness over a period of time. And that is what is happening now. Just because of over usage and improper usage of antibiotics, many microorganisms have started to develop resistance against these antibiotics. Now we are unable to treat certain diseases with the existing antibiotics. And that is the global need, hour of the need, where we want a perfect alternative that can replace antibiotics. When over my conversation, I kept on saying that we need to replace. I'm not saying that we are looking just like an antibiotic, which clearly deposits the era of antibiotics is coming to an end. If you ask a question why, it is all because of this. By 1910, this particular golden era of antibiotic had started. And 1987 was the last year where a novel antibiotic was being discovered. Since then, till date, we are not able to identify one single antibiotic which can uh, work against any bacteria, or we cannot find any antimicrobials that could act against bacteria, virus, parasite, or fungi. So that was the major reason which has pushed us in search of new antimicrobial agents. Moreover, the organisms had started to evolve, making themselves resistant against the antibiotics that has been discovered till date. And you would have now come across certain terms called as XDR. Initially, during the time of our undergraduation and post graduation, we were very much familiar with MDR, multi drug resistance. Now, the organisms have evolved so fast and so quick, they have become extremely resistant to drugs. That is the term that people now use as XDR, which is resistant to extreme level of drugs. Most of the have low glimpses, which you can clearly which can clearly make you understand. And since 1987, the discovery of antimicrobials have reduced. In addition to that, the resistance to those identified antibiotics have started to evolve. So from there on, we are only seeing resistive organisms. So before going into what AMR is, how are we going to identify? First, we need to know what actually has happened, how these antibiotics work. Only when we know this, it would be easier for us to start deciphering things, or to identify or locate where we have to search for AMR. For that particular process, I would like to get into the second level of the topic, that is how the superpower, that is the antibiotics, became a superbug. So, upon continuous exposures to these antibiotics, which usually act on certain areas of the organism, the antibiotics either act on the cell wall of the microorganism, or it inhibits protein synthesis, or it stops the pathways, metabolic pathways that happens within the organism. Sometimes certain antimicrobials are capable of changing or altering the nucleic acid synthesis. So the antibiotics do not act completely on the organism. Instead, they take certain places where they act upon and finally kill the organisms. Just because of overusage and improper practices, when I say improper practices, I would like to quote an example with Mycobacterium tuberculosis. The government usually says to undergo medication for 11 months period, a period of 1 year, close to 1 year. However, the symptoms in the patient stops in the 3rd month or 4th month. Henceforth, these patients stop taking the medicines, believing that the disease has been cured. But what really happened was the symptoms have vanished, but the organism still survives inside the body, which would take another 6 months to get completely eradicated out of the body. Just because certain patients stops taking the medicines after their 3rd month or 4th month, soon after their symptoms goes down, the organisms which is in the dormant state start multiplying, revive, and revive much more powerful, which can be a multi-drug resistant organism. So they won't work for the same antibiotics that was being taken up earlier by the patient. So after 9 months, the person start to recur the MTB, but this time it is going to be a multi-drug resistant organism, or sometimes it can be even extremely resistant to the drug MTB. So this is how things happens in many other cases. The microorganisms which are there existing, say for example erythromycin, which works on both gram negative bacteria and gram positive bacteria. And that is the reason whenever you are being affected with a fever, bacterial infection, people prefer you erythromycin. So it is a broad range of antimicrobial. However, doctors always advise you to take the dose completely, maybe for a 3 days or a 5 days, based on the level of infection. 70% of the patients do not comply with the doctor's choice. Most of the time, doctor says to complete the antibiotic dose, and they also say not to extend it without their consent. These drugs are not to be purchased as the over-the-counter drugs, but public does all the mistakes. They do purchase the medicine over the counter. They do not follow the prescription protocol which doctors are based on the doctor's advice. In certain cases, not knowing or what the fever is or why the symptoms occurs, they simply go purchase the medicine which was being prescribed earlier for some other diseases. All these things have resulted in the present situation where most of the microorganisms have become resistant to the antibiotics. So I had given them the classification. It can be either intrinsic or natural, acquired, cross resistance or co-resistance. In all these mechanisms, our microorganisms have evolved to be a superbug, which became resistant. So this is the exact mechanism that I put forth, where how AMR actually happens, that too specifically when there is a gene transfer. So when X organism is there in Y individual, and he can pass to Z individual with much more higher virulence, and this is how it happens. So the superbug dissemination from one individual who is being affected with an XDR tuberculosis can spread his infection to the community. From the community, when he or she goes to the hospital, from there it can spread to the water body or further to another community. And it reaches out plants, it reaches out farmers, it reaches out to animals, and it keeps on spreading, and it will never stop or it will never end. Thereby, the existence of these resistant microorganisms cannot be halted or cannot be overcome. And now we are pushed to a situation to find a solution in such a way that we are going to combat the antimicrobial resistant organisms. It is not going to be possible for us to completely eradicate from our chain. And the only option left out is to find a solution that could treat it rather than stop spreading it. So if you ask a question, is multi-drug resistance is natural? Yes. It is not abnormal, because every organism which exists on this universe would like to flourish, would like to survive. They doesn't want to die. So it is a natural process that is seen in any organism which fight for its survival, which fights for its existence. So the survival of the fittest is going to be there. So every microorganism will try to push through in such a way that whatever you give, it starts to evolve and it starts to become resistant to the drug or the compound that you give them. They start to become resistant to it. So what are all the present challenges that we see? When it comes to bacteria, the carbapenem, which is given for pneumonia, has become resistant. Fluoroquinolone, which is given for E. coli, to treat against E. coli, has become resistant. Methicillin, most of the research papers that you see now, it doesn't start with Staphylococcus aureus. Instead, we always say as MRSA, methicillin resistant Staphylococcus aureus. Your SRS has changed. It has evolved. It has become resistant to the methicillin, which has been considered to be a perfect antibiotic. As I had already told, Mycobacterium, we were trying to give isoniazid and rifampicin. Now MTB doesn't work for those two drugs and many more. So how are we going to overcome the strategy? So this is the basic sayings that I always say. A bit year old concept. We are going to have a cycle being repeated here, and I do not want to repeat all these things which many of us knew. Now we say that antibiotic is poison because it is not going to treat you. It is going to become more resistant, and your organism, the microorganism, are going to have adverse effect, and they are going to be much more stronger than before. So the situation is nothing but we are going to go back to the roots. Here, roots doesn't literally mean the roots of the plant. what we try to mean here is the natural process of addressing the drug resistant organisms, or a natural process of treating infections, the invaders. So, how are we going to hunt this treasure? The only available thing is natural products. That could be plant microbes by itself, or marine organisms. Any of these things could be a choice. We are not only sticking with only plants. Though my topic starts or my title phrases with plants, my work has been limited with plants. But there are many natural resources that can aid you the process in identifying a perfect antimicrobial. It can be an actinomycetes, it can be any microorganisms which can work for us in the war against microbial resistant organisms. Second most important thing that we need to consider is as how erythromycin has a broad spectrum to treat, our drug also needs to be in one such category. The compound needs to be in one such category. The third most important thing is we have to keep identifying things in such a way that they work for all sorts of culture process. The fourth thing that we can work on is ribosomal engineering. By doing so, we can easily identify an antimicrobial. 5, 6, and 7 are the long range or the future prospects in the identification of antimicrobials. One is high throughput elicit screening, co-culture cultivation, genome mining. By all these means, we can easily look for antimicrobials. So I've just given the explanations in detail here. Genetic engineering is through knockout genes. Co-culturing is to have one species being grown with the other, so that when they start to draw the boundary, we can easily identify the antimicrobials for each other. So silencing a gene is one form of high throughput elicit screening, and genome mining is to identify the genome studies. Based on the genome studies, we can easily extract the information and start working against their microorganisms. And there are certain unconventional screening strategy which I had listed it out here, but these are all yet to be proven and doesn't have a proper literature evidence. We can thereby I can list out only 5 of them. The very first one is endocrinology. It is to target the entire sex cell, and then unconventional hosts like C. elegans and zebra fishes, and all these things could help in identifying antimicrobials when they are being uh, infused or exposed to your resistant organisms. So I would like to put across one particular example where I would like to tell you. In my research process, I had taken one particular disease, which you call it as brucellosis, and it is a very neglected disease, and it affects both humans and cattle. Majorly, cattle are being affected. The disease is brucellosis, caused by two major organisms, Brucella abortus and Brucella melitensis, and it has been rarely considered because they don't cause any lethal concerns. No, there is no reported mortality of this particular disease. But The science says that this particular organism is getting evolved. Sooner or later, we could expect death or mortality would be reported in cattle than to humans. So it is wise choice we start early to find an antimicrobial resistance for this particular diseases. So I took one particular plant which considered to process major phytochemical compounds, which was earlier reported for its antimicrobial property. This particular plant, Tarena asiatica, belongs to the family of Rubiaceae. Most of the plants in this particular family possess antimicrobial property. So what I had performed is, in our study, we had taken this particular organism, we purchased the organism from Pune, then we performed a common agar-well diffusion method. And we were able to report the organism started to die, or we were able to get the zone of inhibition for the aqueous extract of the plant, that is Tharina asiatica. And this zone of inhibition eventually happens at 30 mg per ml against a control which were able to get a zone of inhibition of 14 plus or minus zero 0.4. This is in millimeters. So the work has been published in South African Journal of Botany. This opens up the era for antimicrobials. Here I would like to conclude the talk with 5 major aspects. We have come up with many fundings. Now BioE3 is also onto the roll. The government is ready to fund biological based studies. We wanted to promote investment for AMR activities, carry out research, and do innovate in this particular concept, because by 2050 you can expect a huge loss if we have not discovered a proper antimicrobial. There also needs to be awareness and understanding of AMR via an effective communication, training, and education. We also suggest to have a proper surveillance pattern so that the misuse of antibiotics is further reduced and the resistance among the microorganisms do not evolve thereon. So that is what I had mentioned in the last point. Optimize the use of antimicrobial agents in health sector, animal and food, so that they don't grow or move ahead. So with this, I'd like to end my talk. Any queries, you can post it to my mail ID or you can ask here, because most of us has joined through YouTube. It would be difficult for you to post the question in the Zoom link. So if any personal questions to be put forth on the talk, you can personally mail me to this particular mail ID. Thank you.
Thank you, sir. Thanks a lot, sir. Thanks a lot for your availability.
Yes.
Is there any questions from the Zoom participant? You can directly raise your questions, or as per the declaration of resource person, you can post your question to his email ID also. So regarding, I have one question. It might be simple.
Yes, sir,
Uh,
please.
is it the dog? Is it the dog bite can sometimes lead to superbug dissemination? Is it any
Dog bites can lead to, sir?
superbug dissemination?
Sir,
Uh,
yes. But superbugs are totally different from the concept that we are speaking about. Here,
hmm,
what we speak is the organism that is already existing in our body based on the improper antimicrobial consumption, the antibiotic consumption. The organism that is present in my body gets resistant to the organism, they get converted as superbug. In the same way, for your question, a dog which has been exposed to any of these superbug from human beings can pass the superbug to one another individual through their
the
bites.
spread is, the
Yes,
spread is possible. Am I right, sir?
yes, yes.
Yeah. Thank you, sir. Thanks a lot for your availability. From my bottom of heart, I would like to thank on my own behalf and behalf of the Association of Global Academicians and Researchers. We sincerely thank Dr. Sai Ramesh, Assistant Professor, Department of Bioengineering, Wells Institute of Science, Technology and Advanced Studies, for sharing his valuable insights with us today. Sir, your session was truly enriching and has given a new perspective to think about. We are grateful for your time, effort, and commitment to this FDP. Thank you once again, sir, for being with us and inspiring our participants.
Thank you,
Thanks
thank
a
you,
lot,
sir.
sir.
Thank you, thank you,
Thanks a
sir.
lot. Thank you for your God bless you. Thank you, sir.
Yes.